Welcome back, everybody. We're at it again with our Rob Robinette designed Simplified Soldano Super Lead Overdrive Nakid clone that we built here. Alright, what are we doing today? If you watched the last video, we talked about putting V1 in parallel, the two triodes in V1 in parallel. Well, I'm getting some stuttering on my camera work here. Hopefully that's not getting recorded like that. But anyway, never mind that. We added a unused triode on V1, so we wired it up in parallel. And we're playing around with it a little bit. And at higher gain settings and higher master volume settings, we are getting a little bit of instability, oscillation, squealing, noise, stuff like that. I was watching a video of a guy demoing a couple amps, the SIR, Marshall SIR 34 and 36, what they believe those circuits to be, an amplifier like that. And when he cranked it up, he was, it was making some noise and getting a little unruly itself. So I don't feel too bad, if this amp does get a little bit wild when it gets pushed. But I think we can do better than where we are at now. So that's what we're going to do. We're going to refine our technique in wiring this in parallel and refine our lead dress and our, our whole design work that we did there. And hopefully cut back on the unruliness and get her run as good as possible. Quick note, I'm going to stick with the JJ6V6S's because they can handle higher plate voltage and screen voltage. We need to not forget about the screens. Screens are the most fragile thing in a tube. But anyway, vintage 6V6 rated for 350 or a little more. These are more robust and can handle the 462 volts we are putting on the plate. But anyway, so that's that, 6V6S. Let's pop the back off and put our surgery gloves on, fire up the soldering iron, and make this better. All right, hang tight. Here we go. All right, here we are. Here's our V1. And on the schematic, this is what this looks like. The plates and the cathodes of both triodes are tied together. And then from this point here, each grid has its own grid stopper. And that's about that. And here we are. So we kind of botched this. We gooched it when we installed this mod here. What did we do wrong? Okay. The cathode is this jumper down here. And then the plates being in parallel is this big loop right here. That should have been reversed. The plate should have been the jumper and the cathode should have been a loop like that. Second problem. The grid stopper resistors, as you can see here, these legs are big and long. We're going to go back and we're going to get the leads as short as possible to the tube socket. And then what else we're going to do? We're going to make some modifications. These are 47K grid stopper resistors. We lowered it from the original 68K because it's my understanding that if we had two 68K grid stoppers in parallel, we might be lowering the high frequency response into the audible range. We might lose some high end. The trade-off is the lower you go, the less grid stopping, RF rejection, and stuff like that you get. So there's a balancing act between the value here of RF rejection and high-end, fidelity. We're going to bump these back up to 68K. I think we'll be okay. I don't think we'll lose too much high-end. So that's that. And another thing we're going to do is, we learned a little trick here. We're going to lower this down to 200K for now. We might experiment with the operating point of this tube. We might cool it down a bit because the last thing this amp needs is more gain. It could actually use a little bit less. But anyway, so we're going to get rid of the 220K plate resistor and we're going to put two 100K plate resistors in series. And around the second 100K, we're going to put a capacitor. And what that will do is we will have frequency dependent plate load resistors. Having the capacitor around the second 100K resistor will it's going to bypass some high end, and so it won't be amplified as much. It'll only be amplified as if there was only a 100K on the high end, because the higher the plate load, the more amplification you get. So 200K in series, two 100Ks in series gives us an effective plate load resistor of 200K, except for the high frequencies, which will only be amplified as if there was a 100K plate load resistor. And these tubes will amplify everything, including ultrasonic frequencies, and we don't want to amplify those. We only want to amplify the guitar frequencies. So that's why we're doing that little trick. And I saw that little trick when I was looking at schematics of a, I believe it was the Friedman, Jake E. Lee. He does that little trick there with the, it's a trick. People use it. Oh, Mesa Boogie uses it. They use a lot of tricks to keep their amplifiers under control because they are extremely high gain. So we're going to steal every trick we can learn, and we're going to make this better. Okay, blah, blah, blah. Let's get the soldering iron out and get to work. All right, I drew out V1 and what we're going to do here. So here's the guitar input. We have a 1 meg grid leak. Here's our 2 grid stoppers. 168K going into the first triode. Another 68K going into the grid of the second triode. Our cathodes are going to be tied together. 1.8K cathode bias resistor with a 1 microfarad bypass cap. We may bump this up at some point, but we'll get there when we get there. All right, the plates of the 2 triodes will be tied together. And from our B+, we're going to go to 100K in series with another 100K. And we're going to probably have to play around with this capacitor here to get as little high frequency loss as possible, while also making this stage as stable as possible. And then we're going to clean up the lead dress here, the aforementioned ridiculousness that I did there. Probably going to still use carbon film, depending upon what I have in stock. The metal film are quieter, but it's my understanding the carbon film are a little bit better at RF rejection. So we'll use what we got, but if I have a choice, we're going to use the carbon films. All right, let's do it. And for reference, all right, so the B+ node right here, we have a 15K dropper, we have our filter going into the 220K, so that should be this guy here. Here's our B+, here's our 15K dropper, this guy here. And here's our 220K plate load resistor. Orange wires are B+. And so yeah, so we'll have to put our little 100K in series here somehow. We'll figure it out, make it work.
Make it work.
All right, we have everything all wired up. Oh, we forgot the damn capacitor across the second plate load resistor. We're only going to tack him in anyway because this is a test. This is only a test. Do not be alarmed. Because of this, you know, this is kind of why I left a lot of this stuff extra long, like these guys. These could be shortened. But as you do mods and refine the circuit, you know, these things tend to get shorter as you solder and resolder and etc. This is RG174. The center conductor is really thin. I was looking at some Mogami cable. I think I'm going to get some of that. It has a little bit beefier center conductor, and it should be fine. But that's neither here nor there. Okay, so come off the power supply where you should have a 15K dropper to our filter node. Here's our 15K, here's our filter node, and then off of that we should have our plate loads, which go in 2 directions. One direction goes to the plate, and the other direction goes to the coupling cap. So, yeah, here's our plate load, the 2 100Ks in parallel, and then in the other direction we have the coupling cap. And off of the input jack through the shielded cable, we have our 268K grid stopper resistors, and doing that best I can to keep the grids away from the plates and stuff. Let's see how it works. First things first, we're going to pop that capacitor in there. All I have in stock is 100 picofarad for high voltage capacitors. So we'll start there. We'll tack them in there, and we'll see how it sounds, and then we'll adjust and add salt and pepper as needed. All right, there he is. Mr. Pointer, you're backwards. Right here, this is our frequency-dependent plate load resistor snubber capacitor. So again, B plus goes into here. We have 100K. Oh, wait a minute. That's not going to work. We have this up. The coupling cap needs to be here, not there. Oh, God, what are we going to do? So if anyone doesn't know what I did, B plus comes in here. We have a junction here between these two 100K resistors in series here. And the signal would go out through the midpoint of that junction there. What we've created is a voltage divider. So we would actually be pushing like half the intended or desired signal onto the next stage. So can't have that. Seeing as the tarp board was not designed for an extra plate load resistor, things are getting a little wonky here. The other option, well, we're going to connect this over here. It's going to be ugly, but it'll be good enough for testing. The other option we can do is put it back to normal-ish with the single plate load resistor and put a very small value capacitor across that. So the effect that will have is depending upon the value of the capacitor, very high frequencies, including the ultrasonic frequencies we don't want, will completely bypass the plate load resistor and they won't get amplified. And that should help with stability and oscillation and RF rejection. So that's the backup plan, but for now let's get that leg connected over here somehow and fire up and see how it works. Check it out, fellas. I think we are successful here. Some of the noise is because I'm 3 feet away from the amp. If I walk away from it, it does get a little bit better. Yeah, as soon as I get close, we still have a little bit of stuff going on. But I think once this is in a head shell with a shielded bottom, I think we'll be all right. But when I had the gain this high, we'll turn it to 9 o'clock. In between notes, it would just screech and howl before. you go. So I'm going to order up some parts for this thing, and it'll probably get even a little bit better when I solder all the stuff in for real and we don't have flying leads and stuff like that. But we are definitely moving in the right direction. Oh, wait a minute. Let's put it up to 120. Alright, so here's an interesting thing. Before, in the amplifier's quiescent state, just sitting here, doing nothing, if you'll remember, at 120 volts, where we at 120, we were run 490 milliamps. That's what we were pulling. Now we're at 470, so we're pulling 20 milliamps current less now than we were before. And I can't imagine, 20K on a plate load resistor in V1 is causing that 20 milliamps voltage drop. Bump the button. What I think was happening, I think we were amplifying ultrasonic frequencies. Oh, I got a message. Possibly, we were amplifying stuff that we couldn't hear. I got to build a like a speaker load box type thing, so we can put this sucker on the scope and see what's going on, because it's the only real way to confirm you haven't, you're not amplifying high frequencies is to put it on a scope where you'll be able to see them, because we obviously can't hear them. Yeah, so that's the thing, I guess, for what it's worth. It's a mystery. Alright, so I think the next step here is I need to order some parts. We'll get some real capacitors for our frequency-dependent resistor load snubber capacitor. You knew one of these guys. I probably have these in stock, but we'll fix this jankiness right here. And another thing I think we're going to do, the cathode bias resistor for V1 here is a 1.8K combined with, per stock, a 220K plate load resistor. This thing is, this is pedal to the metal. This is running at the red line. The gain, once you get past like here, none of this is like anything you want. So what I think we'll do is we will cool this down a little bit. We'll change the 1.8K resistor to either like a 2.2 or probably like a 2.7K cathode bias resistor. That will change the operating point of the tube. It'll cool it down a little bit, and it'll run more linearly, and it won't be so unruly and ill-tempered. And hopefully the gain goes from 0 to 100, like from here to here, 0 to 100. And there's some really good tones down here, like old plexi-style tones down here. So hopefully we'll get a little bit more usableness with a little bit less gain. I know it's kind of sacrilege building one of these and complaining about having too much gain, but I think it'll do good things. So it's going to be about a week for me, but in the next clip for you, we should have some more interesting stuff if you're into this kind of thing, I guess. Hang tight. Alright, so here's something interesting that I found doing my research on this here. So on the left here, we have the schematic of our Simplified SLO that Rob Robinette designed. On the right, we have from Headfirst Amps, who is pretty much one of the foremost authorities on everything Marshall, a schematic of what is believed to be the SIR36 amp. That would be the modified Marshall amplifier that Slash of Guns N' Roses rented to record Appetite for Destruction. So the SIR36 is believed to be like a JCM 800 2203, which would be a 100-watt one. The 2203 and the 2204 are both the same thing, except the 2204 is a 50-watt one with only 2 EL34 output tubes. So anyway, let's compare the two here. We have the input, 1 meg grid leak, 33K grid stopper going into V1. First big thing here. The modified Marshall, the SIR36, has an extra triode that a normal JCM 800 would not have. So, and now the SIR 36 and the SLO have the same complement of tubes. So we can see, here's the phase inverter. We got to get the phase inverter here. Phase inverter, they both have obviously push long tail pair phase inverters. But they have this setup here that's driving the tone stack, and that was the DC direct coupled cathode follower. So 1, 2 here, 1, 2 over here. Then 1, 2, 3 more. 1, 2, 3 more. Okay, so back to comparing the two. Input, guitar goes into the amp, 1 meg grid leak, 33K grid stopper. Over here, if we push it over, 1 meg grid leak with a 68K grid stopper. The Soldano has 1.8K cathode bias with a 220K plate load, 1 microfarad bypass. Over here we have the classic Marshall 680 Nano, 100K plate load, and a 2.7K cathode bias resistor. So this is much tamer over here than this guy over here. This guy is at the red line. He's at the limit. Okay, we go through. We have some attenuation. What do we have? 0.02 microfarad coupling capacitor, 22 nano, same thing over here. So that's the same on each side. Then we have 470K resistor, bypass with a 500 picofarad and a 1 nanofarad after that. 470K, same here. This is 2 nanofarads compared to 500 pico, so it's like 4 times as much. Doing math off the top of my head. What else we got? The 1 nano and a 1 nano, so that's the same. This has a 500K volume pot. This has a 1 meg volume pot. So some things are the same, some things are different. This is a big difference. Going into the next gain stage, Soldano has a 470K grid stopper. This only has a 33K grid stopper. I think this is probably the original grid stopper from the amp before it got modified, and all this stuff was chucked on extra into that. All right, 10K, it's very cold, 100K plate load, 10K bias resistor, 100 nanofarad. This is different here. 100K, 1.8K, and a 1 microfarad. So this, again, is kicked up a little bit more. 22 nano, 20 nano, that's the same. We have the same resistor here, 470K grid stop attenuator. This does not have a peaker, treble peaker or bypass right here, into a 330K grid stop again, and Soldano's using a 470 again in conjunction with a 1 meg grid leak. So we're having a little bit more attenuation here. So it looks like on the SIR 36 here, they're not using the tubes, they're not pushing the tubes into super high gain, whereas Soldano is, but because Soldano's pushing each stage into higher gain, he's having to do more attenuation in between each stage to keep everything under control. Moving on, let's see here. Cathode, this would be our cold clipper, right? Yeah, cold clipper. 39K bias resistor. Plate load's 100K. 10K with 100K. That's interesting. These two stages are the same. I remember watching a video that I had first did about this, the two 10K resistors. I don't remember what the information was, but it's interesting. Moving on, 22 nanofarad coupling, 20 nanofarad coupling over here. Things should probably look very similar from here on out. Let's see here, 680K with a 330K and 220K with a 300K. So it's a little bit different on how they're attenuating the signal going into this this DC coupled stage here. This guy here, what do we got? A 1K and a 100K. We have a 1.8K with a 220K. Again, Soldano's just maxing out the gain of every stage possible. Directly coupled into the cathode follower. What do we have here? 100K cathode resistor. And we have about the same here, but it's being split. Interesting. So instead of doing 100K, like here, 100K, but pushing the tone stack off of straight off the cathode, he's making a voltage divider and pushing it that way. So that's interesting. We have our tone stack, 470 pico, 20 nano, 20 nano, 470 pico, 22 nano, 22 nano. That's the same. The potentiometers are the same. Then we have our master volume. This is pre-phase inverter, post volume stack, master volume. And then we have our output stage. Oh, this doesn't scroll. And this looks the same. Yeah, this is the same. So this is a JCM 800 output section, power section. Not power section, but output section. Output tubes, and the phase inverter is all the same. And then after this, it doesn't really matter all that much. So there you go. The Soldano is very similar to the very famous Marshall 2203 SIR number 36. It just kicked up just even a little bit more. I thought that was interesting. Hopefully you thought it was interesting too. Moving on. All right, so I compared this schematic here, which is supposed to be the Frank Levi SIR 36. There are a bunch of schematics that claim to be the SIR 36. This is the one that Headfirst Amps uses, so that's the one we're going to use. We compared it to the Simplified Soldano circuit here, and the topology is an exact match. So, here are all the changes in red compared to the Soldano. Can you see all that? Take a screenshot of that. So what I thought we would do is, I have this extra turret board I made to make a another one of these, but we're going to make one of these in an upcoming video. So tune back in for that. All right, moving on. Parts are in. Let's tweak. Here we go. Oh yeah, one other thing that I forgot to mention that is pertinent. What the hell is on Mr. Pointer? What is that? What have you been pointing at? Pertinent to our discussion of today's video, if we look here, V2, which would have been V1 in the original amp before it was modified. But anyway, second gain stage here, here's the plate load resistor. Well, notice we have a 470 picofarad capacitor going around it, and that is the frequency dependent plate load snubber capacitor. So what this does is lets ultra high frequencies not get amplified by this stage. There's a frequency cutoff, you know, whatever it happens to be at, like, let's say 40K, and then it's minus 3 dB at every octave above that or something like that. I forgot, whatever. But you know what I'm saying, it rolls off the high end, and so we're not, you know, amplifying 92.754 micro megahertz. You know, we just want the guitar signal. We just want like from 80 to 8K, not ultrasonic and not subsonic frequencies, because they will make your amp run squirrely and you won't even know it. But there we go. There's our snubber capacitor, and whoever modified the SIR 36 probably had to stick that sucker in there because she was getting squirrely. Alright guys, check it out. It's the middle of the week here. My mouse order just shipped. I got a bunch of stuff, bunch of cool stuff. We're going to be seeing a clone of this clone. Anyway, I'm looking at schematics and studying and learning, and looking for donor amps to do a, I want to do a Marshall SIR 36 build using a donor Marshall something or other, probably like a JCM 2000 or something. Or I was looking at this Gens-Benz amp that's for sale at a reasonable price. I'm looking, this is a Gens-Benz El Diablo 60. And as you do, you pop up the schematic to see what it's all about. Here's V1. Boop. Here's a plate resistor, and I'm like, oh, what's this? This is different. So we have our 100K plate load resistor. In parallel with that, we were just using, well, we were doing 2 plate load resistors. So imagine there's another one here, two 100Ks, and we had a capacitor around the lower one that gets connected to the plate of the tube. 100 picofarad capacitor there. But I'm looking at this and I'm like, what are they doing here? And what this does is capacitor. This is a high-pass filter, meaning it will block low frequencies. So the low frequencies will go to this path, but high frequencies, and I believe in this configuration, that's like 34, 37 kilohertz. This 470 picofarad will let 34 kilohertz and higher pass through here, and it's got a very small plate resistor, so they're, relatively speaking, attenuated. So ultrasonic frequencies aren't getting, you know, massively Soldano friggin' gained into the stratosphere, and that should make the stage and everything following more stable. And this is a little bit more elegant than what we've got over here, because as you can see here, to accommodate the two plate load resistors, I'm looking through the viewfinder here, but I think it's this guy and this guy here, two 100Ks, and we had to pull the coupling cap off, and we're flying, and we're doing all sorts of stuff. We could put this all back to normal, put the coupling cap back to here, get rid of this guy completely, put our, just a single, probably go back to 220K plate load resistor there, and then in parallel around here, we'll put a 470 pico in series with a 10K resistor here. We'll jimmy that up. And this would be a lot neater, and we're targeting all the frequencies we want. I believe this setup we are attenuating starting around 4K, so we are losing some high end, and we can adjust, you know, the value of this capacitor to raise that up, so we're not attenuating audible guitar frequencies or ones that we, you know, want to use. But yeah, that would neaten everything up. And that's like next level stuff. I mean, this whole thing right here is next level stuff, but this is like next is like second order next level stuff right here. So yeah, can't wait for those parts to come in, and it'll look a lot nicer. I mean, we're starting to look like a 80-year-old RCA hi-fi right now with this whole setup here. Not that I don't like it, I kind of do like it, but you know, we got stuff in, it's a little janky. So yeah. All right, Mouser, let's get those parts. Let's do this. Mr. Pointer, where'd you go? So the Gens Benz amp, here backwards, they're doing this all over the place. This is very similar to a Marshall topology, two gain stages, and then we have our DC coupled cathode follower running a tone stack, and they're doing that trick here too. 820 picofarad with a 4.7K. So, yeah, we're going to do some experimentation, and hopefully we'll have the world's most stable Soldano clone, SLO clone, Nakid, simplified. No, all right, fellas, we did a little bit of soldering, and this is what we ended up doing. This is the plate load resistor for V1 with everything in parallel. We just put a 220 picofarad capacitor in parallel around it instead of doing the 47 pico into a 10K in that gizmo in parallel with the 220K. There's just not enough room here. I have to make it look clean and stuff like that. So that's there, and then over here on V2, second gain stage, we put a 470 picofarad around that plate load resistor. So let's look at the schematic. Right here, we put the 220 picofarad, and over here we put a 470. And we didn't lose a ton of high-end gain, high-end frequency response, which you'll hear in a second, hopefully. And what else did we do? We cleaned up some lead dress. We made this grid wire shorter, more to the point, and we ran them above all this junk instead of underneath like it was before. Clean this up a bit, you know, tried to strategically route plates and grids, strategically, I guess. Anything else? I think we did one other thing with a plate lead somewhere or a grid lead, but I can't remember. But yeah, she's in a much better state now, a lot more stable. I did try plugging in some pedals. You can't really add a whole lot of gain to the front end of the unclean channel here, because she's already maxed out. So if you push in, plug in a clone of an Earthquake or Palisades into this, and you turn the volume and the gain up too much, she's gonna shriek. But you can use it, and you can do the tube screamer into a high gain amp thing, and get all chuggy and crunchy, and tighten up the low end. You just gotta use a little bit of discretion when doing something like that. But we plug this into the clean channel, and yeah, the clean channel. The clean channel is basically the beige construction paper of guitar tones, but it works good as a pedal platform. So bonus right there. You got your Soldano and you got your pedal platform, depending upon which input you go into. Let's plug her in, and you can hear what I'm talking about. All right, I was just looking at this, and I don't know if this is a product of me making a backwards heartboard. Let's take a look over here. Let's take a look. I ain't gonna have this. Anyway, you see this guy here? We have this grid. Yellow's the grid wires. This guy going all the way over here, and this guy going all the way over here, crisscrossing. Probably would have been better to wire the triodes the other way. I mean, you would have had plate leads crossing, but I mean, something's gonna cross. I would think the be better to cross the plate leads than the grid leads. So. Just a thing, if you build one of these, let's see if we can find out where that is. That's the, it's the phase inverter. I guess it doesn't matter all that much on the phase inverter. Yeah, that's how they have it. They have them crossing. Why not have this guy go over here and this guy go over here? Swap this sucker around. I don't know, Rob's a smart guy. He knows what he's doing, but for what it's worth, there you go. Alright, fellas, she's sitting upright once again. We have done all the tweaking I think we're going to do, at least for now. We only did one other thing. We changed the cathode resistor on the V1 tube from a 1.8 to a 2.2K ohm resistor. And that was the final thing right there. Between that and the snubber the snubber capacitors, she's running awesome. She's running great. Talking to some other people, A-Tech had mentioned that he's not a fan of snubber capacitors. He said that they work too good. I don't know if there's such a thing as something working too good, but I think I know what he means. If you don't choose your value correctly or wisely, you will lose high-end frequency response in your guitar signal. So you need to play around with the value. But I think, if you choose your value right, all we're doing is we're sending ultrasonic frequencies. We're just telling those frequencies to piss off and not get amplified. So I don't see much of a downside on that. We may have lost a teeny tiny bit of very high end on the amp, but I don't know. Well, you'll be judged in a minute. And then over on A-Tech's channel, he's building an amp and giving it away. You guys should go check that out. It looks like it's going to be awesome, like some kind of hybrid Dumble train wreck type of contraption. Can't wait to see this sucker finished. Go over there, sign up, win that friggin' amp. It's going to be awesome. Viewer over there, Riley. You need a different username. It's Riley number. You need something easier to remember. But anyway, he built one recently too. And he had mentioned the grid stopper going into V2. If you lower the value of that thing, you can reduce some, shot noise? Or circuit noise. We didn't try that. We might break out the alligator clips and do a little more tweaking to see what we can do. And that, if this thing's going to make noise, he's absolutely right. I would think the grid stopper going into V2 would be, ground zero for that kind of thing. So we'll have to try that. What else do we want to talk about? Nothing. Let's plug her in, see how she sounds. You've waited long enough.
I push my fingers into my eyes. It's the only thing that stops the ache.
Well, there you go. There you have it. Hope you learned something today. I sure as hell did. If you're an amp tweaker and you got an amplifier that's a little bit unruly, we learned some tricks on how to wrangle her under control or something like that. Unfortunately, I'm not the greatest guitar player in the world, so, you know, I can't just whip out some bitchin' licks and do a knob turning demo that would be appealing to everyone. That's why we do these cover demos. I gotta work at it and put effort into it so, you know, I can make something presentable for y'all. But hopefully you enjoyed it. I thought it came out pretty good. Didn't get quite the squealies quite as good as I'd like them to be. But it's not the amp's fault. That's, you know, operator error on my part. They absolutely happen, just not by me, not on command. But yeah, there you go. All right, everybody. Thanks for coming. I want to thank the Petrucci pick for making this possible. I want to thank my Patreon supporters, subscribers, thumbs uppers. Don't be afraid to hit that damn button, guys. And we'll see you on the next one. Oh, speaking of the next one, it's going to be awesome. All right, everybody. Rock on and prosper. Bye, guys.
Done.
Petrucci pick for the win. This is going to save the recording right here.